Folks, we're doing S section from IXL Algebra 1. This is the linear function still, and we're looking at S.15, which is compare linear functions, graphs, and equations. So we're going to see what that looks like. I did not preview it, so should be fun. Let's take a look and see what we got. Let me take off my glasses so I can see what's going on. Oh, is the statement true? A and B are linear functions. Yes, they're linear functions. They're not the same linear function. Oh, the slopes. Okay, so they want to compare the slopes. Well, the slope of function A is 3, and we can see why. Let me point out how I know. We know the y-intercept is at 2, and it has a slope of 1, 2, 3 over 1, which is a slope of 3 over 1. The equation of this happens to be y equals 3x plus 2. And this one has a slope of 4x. So the slope of function A is less than the slope of function B, which is the true statement. And let's take a look here. Oh, there we go. Function A and B are linear equations. Well, let's see. It looks like it's the same equation. Oh, there it is. Okay, there's my new one. All right. This function has a slope of 3 again, up 1, 2, 3 over 1. These are 2 points on the line. You can choose any 2 points where it intersects, and you should be able to count the slope. So this equation was y equals 3x minus 2. And it says the slope of function A is greater than the slope of function B, which is true because it's steeper. The slope of function B, of course, is 2. So function A has a greater slope. Which statement is true? Well, this one has a slope of up 1, 2, 3, 4, 5 over 1. So this equation is y equals 5x minus 4. And this one has a 3x plus 2. And it says the slope of function A is greater than B. So this one goes through 0, 2 and has a slope of up 1, 2, 3, 4, 5. This and over 1. So this equation is y equals 5x plus 2. And this one is y equals 3x minus 1. The y-intercept of function A is greater because, well, it's higher anyway. The y-intercept is at 0, 2. And this y-intercept is at 0, negative 1. Because of the way that they're explaining the y-intercept, they're thinking of it as a value instead of a point, like they should. But of course, we can see that function A is higher than function B, or higher up on the y-axis. Okay, so now we're looking at slopes again. The slope of function A is 2, up 2 over 1. This equation is y equals 2x plus 2. And this function is a y equals 5x plus 0, if you like. We're interested in comparing the slopes. So function A is less than the slope of function B. This time they're asking about the y-intercepts again. Now be careful. This y-intercept is at 0, negative 4 for function A. And function B is at 0, negative 1. Now, one of the things you want to keep in mind is that negative 1 actually is greater than negative 4. And one way we can see that is that our function B is going to have an intercept here, which is further up the y-axis and greater in value. The y-intercept function A is less than that of function B. So It's below it. That's another way of saying that. Okay, we have a 5x, and let's see. This one has a slope of 3. It looks like 1, 2, 3 over 1. Yep. Slope equals 3. This is y equals 3x plus 2. Is the equation of the line. And we want, and that says that the slope of b is greater, so a is less. I'm going to go kind of quick here. Let's see. The y value of function a when x equals 3 is greater than the y value of function b when x equals 3. Really good questions. Okay, so they want us to compare the y values when x is 3, which is right there. So if we look at this function, when x equals 3, the y value that goes with it is 4. So for function a, 3 goes to 4. For function b, y equals 2 times 3 plus 4, which is much higher because y, and another way of saying this is that this is f of 3 is equal to 10. Or we could write it as an ordered pair, 3, 10. So we want to say that the y value of function a when x equals 3 is greater or less. It happens to be less than b, doesn't it? Okay, way more explanation than you probably wanted, but okay, let's take a look at this one. The y-intercept of a is, the y-intercept is 0, 3. And the y-intercept for function b is 0, negative 5. So a is much greater. Okay, the slope for this function a is 1/2, up 1 over 2. The slope is 1/2. And this slope is 1/3. It just so happens that 1/2 is greater than 1/3. 1/3 is about 0.3, and 1/2 is 0.5, isn't it? So 1/2 is greater than 1/3. Slope A is greater than the slope of function B. They want to talk about the y value at 2. Well, when x is equal to 2 for function b, the y value is at 6. So this one is at 2, 6. This one is at 2, 7. Hopefully you can see what I did. I substituted the 2 in and got 10 minus 3 is 7. So function A has a larger value than function B at x equal to 2. Function A and B, and we want to talk about the y-intercepts. Function A has a y-intercept at 0, 3. Function B has a y-intercept at 0, 2. If I substitute the 0 in, I get 2. So function A is greater. It's above, another way of saying that. A and B, we're looking at the slopes. Well, this slope happens to be up 1, 2, 3, 4, 5 over 3. So the slope is 5 over 3. And the slope of function B is 4 over 3. So function A has a larger slope. We're comparing the y value at 6, x equal to 6. We sometimes call this f of 6. For function b, the point is 6, 6. And we're comparing these y values. And if I substitute 6 into this one, 2/3 of 6 is 4. If you need to see it, it's like this. The 6 is over 1, and the 3 cancels with the 6 to give me 2, and that's 4 plus 3, which is 7. So 6, 7 is the a function, and 6, 6 is the b function. So function a is larger at x equal to 6 anyway. Okay, This time we want to talk about the y-intercept again. So this is going to be 0, 2, and this one is going to be at 0, -2. And that's going to be down here. Obviously, the a is greater. And it looks like we're getting there. Want to compare the y-intercepts. The y-intercept for this function is at 0, -5. The y-intercept of this function is 0, -5. Is less is equal. So we want equal. Oh, and the value, good thing I read it, the value of function a when x equals 10 is at 0. This is 10, 0. And let's see, what about this one? And if I put a 10 in here, I get -1. So 0 happens to be bigger than -1, isn't it? So let's take a look and see what it says down here. They're not equal. Function a when x equals 10 is greater. A lot of people are going to mess that up because they're not going to realize that 0 is greater than -1. So we need to be really careful. The y-intercept is less the y-intercepts are equal, or the value of the y-intercept, and the y value at x equal to 10 is greater for function a than b. Okay, that's good. What? Okay, what did I mess up? I said that. What? The y value function a when x equals 10 is greater than the y value function b when x equals 10. That's true. No, it's not. 10 gives me 6 minus 5. It's 1. Oh, geez. It's not -1. It's 1. What am I thinking? Okay, sorry, guys. Messed it up. What I did was when I substituted in 10, I made a mistake, as you can see. 6 minus 5 is 1, not -1. Jeez, what a spaz. Wow, there's a lot of stuff there. Okay, let's fix this. Dang. All right, so I've got to be a little more careful. Looks like we're comparing the slopes. This is a slope of 1. This one, slope is 1. So the slope of function a is larger than the slope of function b. I'm going to write it like this. The slope of function a is greater than the slope of function b. Then I won't mess it up. 1 is bigger than 1/3. And we want to compare, oh, that's all we had to do. Jeez, I can't believe I did that. It's nice to make an error every once in a while, I suppose. Okay, now the slope goes through here, and we go up 1, 2, 3 over 2. So the slope is 3 over 2, which is much greater than half. So the slope is larger for function a, but they ask about -10. Well, -10 has the value -10 for function a. And -10, half of -10 is -5 minus 1, which is -6. So this one is -10, -6, and function b is larger, isn't it? -10 is less than -6. So we say that function a is less. Okay, 1/3, and we're comparing the slopes and at -6. So we want to do two things. We want to compare the slopes. Let's see. Here's function a, it's at 1/3. Function b is, well, it's hard to read, but it's definitely bigger than 1/3. It's up 1, 2, 3, 4, 5 over 3. So the slope of this function b is 5 over 3. Obviously much larger than function a. So function b has a larger slope. Okay, so they only want the one that's true. Okay, so let's compare the y values at x equal -6. So we're going to compare our y values at x equals -6. For function b, that's going to be -6, -6. And for function a, I'm going to be very careful. 1/3 of -6 plus 4. That's going to be -2 plus 4, which is 2. So this one is -6, 2. So clearly function a is much larger than the -6 value of function b. So I'm going to check it real quick one more time. Function a is much greater than function b, and the slope of function a is less than the slope of function b, which is this one. And the slopes are not equal. Oh, the y values that they're comparing for -6. Okay, looks like we got it now. Dang. They're trying to get me there. All right, let's see what we got here. We want to compare the slopes and the y values at -6 again. Okay, so we're going to compare the slopes. This one has a slope of 1/3. That's the function A. Function B has a slope of 1/3, doesn't it? Up 1/3. So the slopes are equal. That's an easy one to remember. And we also want to compare what happens at -6. Well, -6, this one is -2. We sometimes say that f of -6 equals -2. That's another way to say the same thing. And for this one, f of -6 is when you substitute the -6 in, you get 1/3 of -6 plus 4, which happens to be +2. So function A has a larger value at -6 because it's going to be -6, 2. Sorry, it's a little messy there. This one is going to be -6, -2. So the slopes are equal, and the y value on function A is larger. It's not equal. It's not equal, it's larger. So that's the only true statement, it looks like. All right, I'm not gonna mess it up. So we want to compare the y-intercepts, and we want to compare the y values at -4. So I'm going to put the points on -4. Oops. -4 goes to -6 for function A. This is the y value when x equals -4. When x equals -4 for this one, we get y is equal to -3 minus 1, which is -4. If you need to see that, it's 3/4 times -4 minus 1. And the 4's cancel, and you have a -1 there. That's -3 minus 1, which is -4. So a way of writing that as a point is -4, -4. Now, one thing you want to keep in mind is that -4 is actually larger than the -6. So the function b has a larger value, or has more value, when x is equal to -4. So let's see. What about the slopes and the slope? Oh, we haven't compared them yet. Let's see. The slope over here goes up 1, 2, 3, 4, 5/2. And 3/4 is much smaller than 5/2. So the slope of function A is larger. So, oh, the y-intercept is what they asked for, 0,4. Sorry, gotta pay attention, 0,4. And this one is at 0, -1. So the y-intercept of function A is greater than the y-intercept of function B. Okay, it's higher up, yeah. And at -4, function A is less than the y value of function B. That's it. Okay, definitely no guessing on these. Okay, we want to compare the y-intercepts, and we want the value at x equal to 10. Okay, so we're comparing the y-intercept. This one is at 0, 4, and this one, of course, is at 0, 0. And then we also want to compare, what else was it? The y-intercepts and the value at 10, 10, not negative 10. So this one has a point at 10, 6. That is the value of the function when x equals 10. When x equals 10 for this one, we get 10, don't we? Substitute it in yourself and you'll see. 10, 10. And this one is larger. So function A is larger when x equals 10. It's greater. And the y-intercept of function B, function A is greater than the y-intercept of function B. It's like that's it. I'm just going to double check by reading the other two. It looks good. And we have one final one, and then we're done. We've got y equals 5 halves x, and this one has a slope of 1/4. I wrote the equation for that one. So we want to compare some other things. Let's see. We're comparing the y-intercepts. So this one is at 0, 2. The y-intercept is at 0, 0, 2. This y-intercept is at 0, 0. Hopefully you see why. If you substitute 0 into this guy, you get 0 out. So the y-intercepts of A is less than B. So that's one of them. And then we want to compare the values at negative 4. So this one is at negative 4, 1. That's a value of 1 for the y value. And this one, if I put in negative 4, I get negative 10. 4, negative 10. So clearly, this value is much higher than the function A. Let's see what it says. Function A not equal, and function A is not greater. They're not equal, and function A is not greater. And it looks like that's the only one that's true. The y-intercepts are not equal. That's it. Looks like we're finished, guys. And hope you all are going to be able to get to your 100, and I'll see you back again. Bye. Silly thing, gotta move my mouse around.